Guys, know you did well on this. All right, here we go. Just like who's here we go. That is Daniel Cook. Here we go. Although you guys don't know who Daniel Cook is. You're too young. Yes, you know who Emily Young is. Yes, because Daniel Cook got too old and his voice broke, so he couldn't be, this is Daniel Cook going to the aquarium. So they had to get a younger kid, and it was Emily Young. You guys know who that is, right? This is Emily Young at the aquarium. She goes, here we go, and then they go to the aquarium. Yeah, the little Asian girl. Yeah, she was not as good as Daniel Cook. Now, funny story, I grew up with a friend whose name was Daniel Cook. So every time I saw him after that kid came out, Dan, here we go! He got really mad. He didn't like it. I also had a friend named Owen. And if you've seen the movie Throw Mama from the Train, there's a horrible mother character in it who is always yelling at her son. And her son's name is Owen. And she goes, Owen! So every time I said Owen's name, Owen! He got really, really mad. One time we were having a few beers and he punched me in the nose. Because I had stopped calling him Owen, but when you have a few beers, you do stupid stuff. And he walked in the room, and he walked up there, and I was like, ow, but okay. Because he was right. He'd asked me to stop a million times. And, of course, if you systematically do the same bugging of the same person over and over again, that is actually bullying. So I was bullying Owen a little bit. And he was a skinny little wussy guy, so it didn't really hurt when he hit me in the nose. I mean, it hurt when he hit me in the nose, but it didn't really hurt when he hit me in the nose, if you know what I'm saying, right? It's like when your little sister and accidentally hits your nose. It's like, oh, and you check for blood, but it doesn't really hurt. It was kind of like that. I did that thing. Oh, all right. So let's do math. A number that can be expressed as a product of two equal factors. Pardon? F is absolutely correct. If you don't have F, you should write the right answer and put a big X beside it. A number that can be expressed as the product of three equal factors. Karen? E, as in perfect cube. 3, the number 5 is the base. A. 4, one of two equal factors of a number. H, nice job, Micah. 5. C, that is the exponent in diddly-doo. 6. G, as in golly, I'm good at exponents. And 7. B. Give yourself a mark out of 7. Please do it now so you don't have to count later when I say, what'd you get? And you say, I'm just counting. You have 7 right there because all of you's got 7. 8. D, as in, damn, I'm kicking this review's rear end. 9. E, as in index. Yes. When you look up good math student in an index, you see pictures of you people. It's gonna be difficult to do. Carry on. 10. The number 25 is the A, as in awesome. 11. F. 1 and a radical, the root of 6. Do we write 1? So it's an entire radical. 12. 12 is C. It's a mixed radical. 13. D. We use D again. 14. B. Give yourself a mark out of, guess what? 7. And might I congratulate you on being the first class ever to actually have read this part of the instructions and not complained about using D twice. Well done, Block A 2018. Good job. polite golf clap for being the first class in 20 years to actually not do that. Now, somebody yesterday did do that. Somebody yesterday did get a little confuzzled that the process of elimination wasn't working. But I think it was somebody in the other class. It was you?
No, I didn't say it.
Oh, okay. All right. Way to own up, buddy. When multiplying powers that have the same base, what do you do with the exponents? Add. Now, silly me. Add. Now, some of you are going to be in grade 3 and you're going to say, you plus them. Some of you wrote plus there. I know you did. That's okay. I will allow it. Some of you will write that symbol there. That's okay. I'll allow it. Who wrote plus them? Somebody did. Come on. None of you?
I didn't. I promise you I didn't. Let us just be annoying.
Okay. To simplify a power of a power, what do? Multiply. Some of you, I know you did it. You wrote times them. Who did it? Somebody wrote times. There is no way this entire class, nobody wrote plus and times. All right. I'll choose to believe you. That is another first for Block A 2018. You guys are on a roll. Any non-zero power raised to the exponent of 0. Give yourself a mark out of 3, making that whole page out of 17. How many people are rocking at least 12 out of 17? Let's change colors. What's feeling good today? None of those colors are inspiring me today. Orange? Yeah, or orange. Okay, we'll go orange. The result of raising a fraction to a negative exponent is the same as the result of raising what of the fraction to the positive exponent? Reciprocal. How many of you wrote the flip? Excellent. 15 or 5. The expression 15 to the 1/2 is equivalent to the square root of 15. Excellent. Would I deduct a mark if you didn't write the 2 there? Of course not, because you're not supposed to write the 2 there. Would I deduct a mark if you did write the 2 there? No, of course not. Would I deduct a mark if you wrote the 1 there? Of course not. But should you? No. This is what it should look like. 1024 as a power of 4 is, if I am not mistaken, 4 to the 5th, I believe. 4 times 4 times 4 is 64 times 4 is 256 times 4 is 1024. Yes, 4 to the 5th. The edge length of a cube with that volume is 7. Because, of course, it is the cubed root of 343, which I also will accept. You think.
I'm sorry that I'm late.
Shocking. I'm appalled. No, I'm not. I'm a Matt. Appalled. A Matt. Because my name is Matt, not Paul. Yeah. That's okay. I called you Daleric for the first couple of days. So, Charles. The value that makes this true is -3. Because if that x was -3, you would reciprocate to 3/4. And 3 cubed is 27, and 4 cubed is 64. That's one you should put a little star by, because that's something that a lot of you, When you see a negative 3, you're like, oh, flip it, no problem. But when you don't have the negative 3, a lot of people are like, I don't know. Okay? Okay. This mixed radical is the fourth root of 405. Does everybody know why, or do I need to explain it? Okay. If there's a 3 out there and it's the fourth root, then how many 3's had to be under there? 4 of them, right? So that would have been the fourth root of 5 times 3 to the fourth. 3 to the fourth is, of course, 81. 81 times 5, 80 times 5 is 400. 1 times 5 is 5. 400 plus 5 is 405. Gouda? Great. And, this is a tricky one. When expressed as a power, what does that symbol that I've just made orange mean as a power? 1/3. What does this that I have highlighted in green become when I make it a power? The base. So that becomes m squared over n cubed to what power? 1/3. Is that power? Or do we simplify? Simplify. It is m to the 2/3 over n. Because 3 times 1/3 is 1. If you got this, you may have your 1 mark. Because I'm in a good mood. Would that get you a full mark on the test? No. If you went the one step further, you may have a bonus 1 mark, which means it's possible to score better than 100% on this, even though better than 100% is impossible, no matter what your sports coaches say. Okay? If you didn't get that joke, I'm sorry. But it was a good one. You should have. Prime factorization of that giant number. Oh, Mr. Myers, I don't want to prime factor that. But you have to. It ends in 4, so what do you use? Of course you use 2. 9,604 divided by 2 is 4,802, which ends in 2. So what do you use? 2, which is 2,401, correct? Which 2 plus 4 plus 1, that's not 3. I can't use 3. It doesn't end in 0, so I can't use 5. It doesn't end in 5, so I can't use 5. What is the next prime number you should try? 7. And does 7 work? Of course it works, because it gets you 7 and 49, which then, of course, is 7 and 7. So now, what do we look for? There's all our prime factors are highlighted in green. What am I looking for? It gets you 343. Thank you. 343, which gets you 7 and 49, which gets you 7 and 7. Now, all of our prime factors are circled. So what size group am I looking for? Groups of 2. Is there a group of 2? 2. Is there a group of 2? 7. Is there a group of 2? 7. Did I leave anything under there? Did I leave anything under there? No. 2 times 7 is, of course, 98. So that is the answer. I am offering 2 marks to you for that. Now, 2A could have gone in 2 ways. Derek and his crew were like, oh, Myers says no calculators. So he went really hardcore, which was this. He said, since this is a square, he knew that square A had an area of 5.1 squared, yes? Right? And square B had an area of 3.5 squared. Now, what I said to do was write and evaluate an expression using exponents. Is that an expression using exponents? And could we evaluate that if we use our calculator? Of course. We would do 5.1 squared plus 3.5 squared and get an answer. And that would have been perfectly acceptable because you followed what I asked you to do. Derek said 51 over 10 squared plus 35 over 10 squared, which was then 51 squared over 100 plus 35 squared over 100, which is something like 2,725 or something. I can't remember what 51 squared is. Whatever it is, plus 1,225, whatever that was, over 100. And then they added that, and then that's where you would have stopped, which would have been perfectly acceptable too. Everybody with me? Everybody sees what Derek did here? Oh, it's not over 100. Yeah, it is over 100 because we've squared it. Yeah? Both of them are good. I'm happy with either one, whichever one you did. Okay? I don't remember what the actual value is. It's going to be something like 25, and it's going to be something like 37. 38? Okay. And then same thing down here, yeah? It's the exact same thing. Why did I give you the same question twice? Because I changed this to yards to see if I could fool anybody into doing some conversion back to feet. Did you need to? Of course not. Because the side length, doesn't matter what you're measuring it in, the side is 4.3 of them. So the area is, of course, 4.3 squared. No matter what the area, no matter what unit we have. Then, of course, you did the same thing here. You did 4.3 squared plus 9.3 squared to get something like 18 and 85, something like 103. Okay? Or you did this move, 4.3 over 10 squared plus 9.3 over, or 93 over 10 squared, and then you did it all. Okay? Now, which one shows me more understanding of math? The second one, right? That shows me you are all over exponents. Right? You're inside out. You are there. They are your female dog. Understand? Okay. In real life, which one is the one you would go to Home Depot with? The first one. Everybody cool? Yeah? But they're both equally good. And you can have 2 marks for both. 2 marks for both A and B, not 2 marks. You know what I mean, right? Okay. Holy Toledo. This is like the tag team questions on the board, yes? There is more than one way to do it. So if I start doing this and it looks nothing like yours, should you be stressed? No. Until when? At the end. If I have something different from you, then you need to ask, right? Okay. The way I personally would do this, I would start in there. Did everybody start in there? Or did you bring that 2 in? Okay. I start there so I don't have to distribute that 2 6 times. So what I did is I got a cubed, b to the 4th, c to the 6th. And all that is squared, and I didn't touch the bottom yet. Right? Then my next move would have been the 2. So I only had to do it 3 times, which would have gotten me A6, B8, C12. Yeah? Okay. Then my third move would have been this 3, which would have gotten me B6, C15. Then I would go up and down to get A6, because there's no A's on the bottom. 8 minus 6 is positive 2, so I'm going to leave it as positive 2. Now, some of you will have an issue here, and I'm going to show you what I mean right there in a sec. That is b squared. This 12 minus 15 is c to the negative 3. And what bothers a lot of you guys when you're doing this question is you say c to the negative 3, and then you forget where it is. and you're not sure what to do at the end. If you aren't going to learn what is actually happening and you're going to stick with just the shortcuts, then when you get to this spot, you no longer have numerators and denominators. Okay? You are bringing all the exponents up to a numerator, and then you will move later. Does everybody understand? I don't like to do it that way, but I have found over the years that no matter how many times I show students what is going on, they go back to the exponent laws. So what's really happening here is there's 12 C's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, on the numerator, yes? And there is those same 12 C's and 3 more in the denominator, correct? So those 12 will all disappear, and those 12 will disappear, leaving me with 3 C's in the denominator. Okay? You decide what works for you. That's the final answer. It's going to be out of 3. You decide where along the way if you don't have this. You decide where you messed up. So basically you had to do 3 simplifications, yes? So if you screwed up one of those simplifications, take away a mark from yourself. Mike, is your hand up, or are you just showing off that your arm is taller than me? Okay. When you're 8 feet tall, it's not fair to short people to stretch. Because you're far away from me, so you should look short, but you still look gigantic. It's hurtful to me. I'm just kidding. Stretch all you want. Is everybody good? Making that page out of 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 with the possibility of 1 bonus mark. How many people are rocking somewhere in the 20s? Nice. All right. This is worth 2 marks. You're going to get 1 for doing it in the right order, and you're going to get 1 for your description. Notice how I did not say anything. So one method you could have done is you could have done all this on your calculator and gotten decimals, yes? 16. Right? You could have done this on your calculator and gotten decimals. Because I didn't tell you not to, did I? And those decimals would have been estimates, but they would have been good enough, right? So 1, you could have used calc to decimals, and then put them in order, big to small. Right? That's 1. If you did that, that's cool. The other way you could have done it was, this is the cube root of 40. This is the square root of 30. This is the square root of 64. And this is the square root of 54. Right? Now, you know that that is less than 6, that is 8, and that is slightly more than 7. So they're in easy order, correct? And then this one, cube root of 40. Well, you know the cube root of 3. You know the cube of 3 is 27, and the cube of 4 is 64. So that's got to be between 3 and 4, yes? So now you can just put them in order. 8's the biggest, so it was root 64 first, which was 4 root 4. Then it was root 54, which was 3 root 6. Then it was root 30, which was root 30. And the smallest one was 2 cube root 5. That's the order you would need it in. Now, obviously, whichever method you used is going to be evident when I see the work, yes? So either you, 1, calculated estimates, or 2, you went entire radical. I can't think of another way to do that. Does anybody else have another way to do it? That's the only way I can think to do it. One of those 2. Everyone's cool? All right, so give yourself a mark out of 2. This is, of course, 3 root 5 for 1 mark. Everybody knows how to do it, yes? Because that is 9 times 5. Out comes a 3, the square root of 9. This is, of course, 2 cube root 5, because that is 8 times 5. Out comes the cube root of 8 for 1 mark. Everybody still good? 243 is, of course, 81 times 3. So out comes the square root of 81, 9 root 3. Everybody good? Once, twice, thrice? Spectacular. As a power, 3 to the 5/4. Everybody good? This one's a little trickier. If there was no y, that would be x to the 4th to the 1/2, correct? If there was no x, then that would be y to the 3rd to the 1/2, correct? If you got there, you may have the full mark available to you. But what do I really want? X squared over y to the 3/2 to get your +1 bonus mark. This is where you need to be on a test, because you would never leave something not wholly simplified, right? Everybody good? Derek. Why is this 1/2 here? Because that's the square root. Remember? 9 to the 1/2 is the same as the square root of 9, because the numerator becomes the index, the base becomes the radical, right? Everybody cool? Marcos.
I put x before it over y to the 3 and the multiple thing in brackets and
So you had x4, y3, all to the 1/2. That's still 1, but you can get your bonus mark if you actually simplified it out. Okay? This is still right. Okay? All right. Is everybody good? Sweet. And this one. Oh, Tricky McTrickleton. Well, what's the radicand? Son of a... What's the radicand? I know. The radicand is 64n, right? And all that should have been to the 4/3, right? Okay. So that's one way you could have written it, and that's cool. That I'll give you your 1 mark. You also could have written this, 64n4 to the 1/3. That would get you your 1 mark. Okay? Are either of them good enough for a test? No, because 64 has a cube root, doesn't it? So that is really, what's the cube root of, simplify here. What's the cube root of 64? 4. And you could either do this one of 2 ways. That's n to the 4th, right? So I'm looking for a group of 3, yeah? Right? So I could bring out an n, and that would leave 1 n under there. Under there. Thank you. Which would then be 4n, and then n to the 1/3, which would be 4n to the 4/3. That's the best answer you could give me. Does everybody understand that one? Because that one's a little tricky. Because the 4n was out here, and then the cube root of n was n to the 1/3. And then n times n, they're the same base. So this is n to the 1, which is really 3/3. 3 plus 1 is 4/3. But that 4/3 doesn't apply to the 4 anymore. Because of here, if I apply it here, that's going to be 64, right? And to the 4/3 and n to the 4/3. And then it's going to mess itself up. Or It's this one, cubed root of everything. Cube root of 64 is 4, and that would be n to the 4/3, because 4 times 1/3 is 4/3. Okay? This is your best answer for your +1 bonus mark, but I will accept anything highlighted. Okay? Does everybody understand why? Yeah? Okay. I want to show you something over here because some people are a little bit, I don't believe you that you quite get it. If I gave you this, 9 to the 3/2. We talked about that becoming the square root of 9 all cubed, right? Right? What is the square root of 9? 3. 3 cubed, which is 27. Yeah? Now, what I showed you there was this. The root of 9 cubed. Right? Because I had the 64. I brought the 3 right under the radical sign, didn't I? Everyone agree? Now, isn't that the square root of 9 times 9 times 9? Okay. What is the square root of 9? 3. So what comes out? 3. What's the square root of 9? So what comes out? 3. What's the square root of 9? So what comes out? 3. Did I leave anything under there? Under there? Thank you. What's 3? What's 3 times 3 times 3? 27. See how they're both the same? Everybody with me? You can either put the 3 outside like we did, or you can put it under the radical. You're going to get the same answer. Everybody cool? Because this is saying the square root of 9 cubed. This is saying the square root of 9 and then cube it. Everybody good? Okay. No more of that joke, Derek. It's all right. I promise. Dice rolling game, there's 8 contestants. If the number rolled is 8, the contestant must leave the game. The last one remaining wins a prize. How many rolls are expected? Can you give me an exact answer? No, because is it possible that all 8 people roll an even number the first time? It's possible. So we're only talking about expectations, yes? So after one turn of the dice, one turn of the game, how many people are out? How many would you expect to be out? 4, because half of them you would expect to roll odd, yes? So round 1, I'm going to be down to 4. What happens in round 2? I'm going to be down to 2. What happens in round 3? I have my winner. So how many rolls were expected to get a winner? This is where you had to make a decision. You could say it's 3 turns, right? 3 rounds of the game, 3 rolls, gets me a winner. I'll accept 3. I assumed common sense everybody would say 3, but one kid one year said, well, Mr. Myers, isn't there 8 rolls in the first round? Because 8 kids all roll the dice. And then isn't there 4 rolls in the second round? And then isn't there 2 rolls in the third round? So don't I really need 14 rolls to find a winner? The dice have to roll 14 times, which I will also accept depending on what you did. But which one applies to exponents and roots? The 3 or the 14? The 3, because we started with 8 and we got down 3 rolls to get down to a single factor. Because 8 cube root, right? 2 cubed is 8, because we're losing the roots every time. Everybody understand? And I'll accept both. That's worth 1. So that page is out of 1, 2, 3, 4, 5, 6, 7, 8, 9, with the possibility of 2 bonus marks. Yeah. Page out of 9. All right. So this page, you're going to get 1 for finding Amy's error And you're going to get 1 for the correct solution. Now listen to me. Sometimes I give you these questions, which are a lot like the tag team question on the board, right? You're stuck working with someone else's work. You might not have done what they did, but you got a spot where they went wrong, right? It's exactly like me marking your guys' work. Because I have a way I would do the question, and you might do something totally different. I'm like, oh my goodness, that does not look anything like, okay. Wait, oh, yeah, oh. And it makes it harder because half you do your work in pen, and there's arrows everywhere. I screwed up over here, so take this answer, then go up over here, and then I'm going to do some work there, and then, I screwed that up, and then you scribble all that out, and then you bring this arrow, you scribble out that arrow, and then you bring it over here. Please stop. Do your work in pencil. But back to what we were talking about. You're stuck with Amy's work. So, we're starting here. Are you happy with Amy changing that fraction to that decimal? Is that right? Is negative 1/4 the same as negative 0.25? Yes. So no mistake there. Now, I am doing division here, yes? So what should I do with my exponents? Damn it. I should minus them. I should subtract them. Excellent. Did she subtract? No. What did she do? Added. So where's her mistake? Right there. What'd she do? She added. Now, why did she add? Because she was trying to do it as quickly as possible and not show work. She said, subtracting a negative is the same as adding a negative. It's not the same as adding a negative. It's the same as adding a positive, yes? So this is a mistake. How could she have fixed it? She could have done negative 0.25 plus, don't need a bracket, plus 0.75, right? Or she could have written negative 0.25 minus 0.75. Both of them would make her teacher happy because that's showing the right thing to be done, right? So there's her mistake. That gets 1. Yeah? Because the rest is correct. Now, if I was marking this and it was out of 3, what would I give Amy? She did this right. Now, she made a mistake here, but did she do this right? 3 to the negative 1 is 1/3, isn't it? So what do you think I should give her out of 3? 2 out of 3, that's a C+. That's 67%. Didn't she miss a pretty significant part of this? So what should I give her? Should I give her 0? Or does she prove to me that she knows something about exponents? Something about exponents, correct? So what should I give her? I'm giving her 1. I'm not going to give her 0 because she knew some exponent laws. Okay, that's how I mark your tests. All right? That is what I am weighing with every question. Do you have an A, a B, a C, or C minus? Answer. Okay, what did you show me in your work so I can give you credit? Everybody with me? All right, that's just a sidebar. So we've all done her mistake. Everyone corrected it. Everyone has their 1 point. Give the correct solution. So 3 to the negative 0.25 plus 0.75 is what? I can't do that in my head, Mr. Meyer. Sure you can. What is it? 3 to the positive 0.5, correct? Which is 3 to the 1/2, correct? Which is the square root of 3. Do you need that 2 there to get full marks? If you didn't have that 2 there, do I deduct? If you did have that 2 there, do I deduct? No. Can I guarantee future teachers won't? No. But for me, you can leave it that way. Is everybody good? Making this page out of 2. Making the whole thing out of 2 and 9 is 11. 11 and 16 is 27. And 27 and 17 is 47 minus 3, 44. 2. Everybody good? Now listen. I'll let you add it up for a sec. When are you going to give me this mark? Well, half of you aren't going to give me this mark at all. Half of you are going to not write it on your test, even though I'm going to remind you today and on Friday when I hand you your test. Half of you still aren't going to do it. My grade 11s, I gave a test yesterday. Warned them. Write your review score. 1 out of 30 did it. 1. So, half of you aren't going to remember, but I'm going to remind you now. You're going to report this to me on your test on Friday, yes? Now, listen. I know that you guys feel that, because most of you probably did okay on this. You feel good. You're feeling strong. And what happens on this is everybody does pretty well on this. And then they think they've got it, so they don't do any more practice. Right? Now, I call your attention to this question. That's a very busy question, isn't it? Right? Just because you nailed it once, don't feel that you should be resting on your laurels. Okay? Because there's a lot of stuff I could do to that question to make it slightly different, couldn't I? If I did this, does that change it? Does, doesn't it? Not significantly. Now, the 12 disappeared. Now it's just 12 times 1 squared. So what's this numerator going to have in it? 12 squared, which would be 144. So this numerator would have a 144 in it if I added a 12 there, yes? What if I added a 2 there? Then that 2 would square 2, wouldn't it? So that would be 12 squared times 2 squared, which would be 144 times 4, right? So that's what would be here. Yeah? And what if I put a 6 down there? I would have 144 times 4, and it would all be over 6, wouldn't it? Then what would I have to do with just those numbers? Do the simplification of fractions, yes? Everybody with me? Don't forget what you already know because you're feeling a little confident right now. Right? I mean, choose anything you do with your time. If you feel confident, when it comes to time to perform, do you still rehearse it? If you're in dance, if you're in a play, if you play a sport, do you stop practicing the second you do that play just right in practice? Of course not. Do you stop practicing the dance move when everybody nails it once in rehearsal? Of course not. So please, 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 I know that you're feeling better than you were 2 days ago. I know this because as I look out at you, I am seeing smiles and nods and people adding up their numbers and being like, don't think, okay, I got this. Make sure you give it a look tonight and tomorrow, okay? And of course, tomorrow for warm-up in math, I'll put up some exponent questions like I did 2 days ago when we did the little, everybody come up to the board and do their thing, okay? I'm not going to forget about it. By the same token, I know some of you heard all that and think, oh man, that means he's going to give us impossible things on the test. I'm not. It'll be things like exactly what I just showed you. I might add a number out front. Okay? That's what I mean by adding layers to it. I'm not going to do crazy stuff. Karen.
For the test, are you going to do like the multiple choice asking thing where you like what we did on
Oh, the matching?
Yeah.
I don't have any of that on there because I don't really dig that matching. I don't like it because no matter how many times I say you can repeat answers, kids still do the process of elimination. And then they're left with answers and they leave stuff blank because they think, even though I say right on it, you can reuse answers. And I don't like you to lose marks on things like that because you're not thinking straight. You understand? I like matching for studying because if you don't use the exact words I use, you actually have to think about what it is. but that takes time. And I don't want you to waste test time on something as trivial as if you use the same words as me. Okay? Does that explain? Okay. So otherwise everyone is good and ready to go? Okay. If you would be so kind then to turn to page 118. The first lesson is all grade 9 stuff. You already know how to do... I shouldn't say that. You should know 90% of the first lesson already, depending on who your grade 9 teacher was. Some of you will know all of the first lesson already. Okay? Haram. I'm sorry, I can't hear you, Haram. You're telling me your score? No, not yet. Tell me on your test on Friday. Okay? Then all of you already know how to do lesson 2 from our square root unit. You will know how to do that. And you'll probably know how to do 3 from our square root unit. This is where grade 10 is going to start. And I'm giving you fair warning. This is the first unit that I can't begin to explain any time in any case where I could give you a real life example of this helping you. Okay? Surface area, trig, all that happens in real life. Square roots, they happen in real life. This doesn't. This is where we start getting away from real life math and into math for the sake of doing math. Do you understand what I'm saying? This right here is where, for lack of a better word, A and W principles end. Okay? This is where pre-calc, because this class is foundations and pre-calc, yes? This is where pre-calc starts. We are going to dip back into foundations in units 5, 6, 7, and 8. But this stuff is integral to going forward in pre-calculus math. This is where, if you've been kind of dogging it along the way, this is where, if you want to do pre-calc 11, pre-calc 12, and go to university, this unit is utterly important. Useless in real life. Utterly important to carry on in math. Like, you can't do any math past grade 10 unless you're good at this unit. Everybody cool? That's not to say it's difficult. It's just new. Okay? Everybody good? All right. Let's wake up your brain to what you already know. You all should have had polynomials described to you last year. Every one of you, right? Polynomial is simply an expression. Now, we all know what an expression is, right? Is this an expression? No, because it's got an equal sign and we can solve it. Yes? That x equals 4, right? Because 4 plus 5 is 9. That's not the real reason. The real reason is because 9 minus 5 is 4. Everyone's cool with that, right? That's an equation. This is an expression because you do not know what x is. So we have to leave it. Does everybody understand? All right. So a polynomial is an expression, which means you cannot get an answer. You can only change the way it looks. Okay? So polynomials are an expression containing variables I got to erase that x plus 5. variables, coefficients, and constants. Now, you should know what all those words mean, but if I were to guess, I would say you might have forgotten what that word means. What is a constant? What does constant mean in English? It stays the same. I am constantly doing bad jokes. And I will constantly do bad jokes. That will never change in this class. Understand? So, in this example up here, there are two constants. What are they? No. The constants are 5 and 9 because we know what they are. X is a variable because we can write a lot of different things for X. We know it's 4, but couldn't I write 64 over 16? Wouldn't that also equal X? Everybody picking up what I'm putting down? So a constant is just a number because you know what it is and it's always that. What's a coefficient? We just did this in our unit on radicals. What's the coefficient? The number that multiplies the expression. In this case, it's the variable. So I'm going to write something out here. 3x plus 4. And I'm going to highlight each thing. Where's the variable? It's the x. Does it have to be a letter? No. When you were learning how to do math in grade 1 and 2, the variable was a blank, wasn't it? 3 plus blank apples will give you 8 apples, right? The constant is the blue one. That's the 4 because it's always there. And the coefficient is the son of a... The coefficient is the 3 because it modifies the variable. Is everybody cool? We know 3 is always 3, but the value of this whole thing is variable because we don't know what x is. Everybody cool? That's why that 3 is a coefficient. Yeah? Okay. Monomial is an expression with any combination of variables, coefficients, and constants. Any combination of them joined by multiplication. So, 3q, is that a monomial? Is that a combination of variables, coefficients, and constants? Or, I kind of wrote that badly. Is that a combo of made up of one or more of these? Yes, because it's a variable and a coefficient, correct? Is it joined by multiplication? Yes. So it's a monomial. Everybody cool? What about this one? 4xyz squared. Is that a combination of coefficients and variables joined by multiplication? Yes, because that's 4 times times times. It's all multiplied, so it's still a monomial. Everybody cool? What about this? So that's okay, that's okay. What about this? Is that okay? No. Why? Because it's combined by adding. So that's not allowed. Everybody cool? No matter how many variables I string together, as long as they're all multiplied, it's still a monomial. Mono for one. Like monocle, one lens of glasses. Okay? You know, like all the bad guys in old movies used to wear? I tried to get my mom to let me have one of them in grade 9, and she said no. Bitch. All right, everybody good? Because in grade 9, only one eye was bad. My left eye had perfect vision. Only my right eye was bad. I walked around in circles. Nothing?
That was terrible.
All right, so monomial is 1. What's a binomial? Yes. 2. So a binomial is 2 monomials joined by what? If multiplying joins into monomials, what must join the two monomials? Addition or subtraction. So, is this okay? 3q minus 7. Yes, 3q is a monomial, 7 is a monomial, because it's just a constant and they're joined by addition. That's okay. What about this? 3x squared y squared minus 2xy. Is that okay? Yes. What about this? 3x squared plus 2x plus 1. No. Even though that's x and x, I can't put them together. That's not okay. What about this one? 3x squared plus 3x squared plus 3x squared. Is it? Isn't that 9x squared? So what is it? As it's written here, what is it? It's not okay, is it? But when I simplify it, it is. Now, but is that a binomial or a monomial? That is actually a monomial. Is everybody cool? What is the lesson I'm trying to teach you there? When do you simplify? Always. Do not rely on first appearance. Okay? And finally, being the intelligent young people that you are, if a binomial is 2 monomials, what's a trinomial? 3 monomials. Joined by what? Addition or subtraction. Right? So 2x squared plus 3x plus 7. Okay? Everybody good? Yo.
So that one was not a trinomial.
Because you would simplify it down. You would never leave it like that. Okay? Because it's not really 3 terms. Now, let me ask you this. Do you think that this is a binomial? Or a polynomial? The polynomial is monomial, binomial, trinomial, or any bigger. We don't go past 3, just like we don't go past cubes with the special names. Do you think that is okay? Is that a polynomial? It's yes or no. I haven't told you. I'm asking you if you think it is or isn't. Polynomial is a combination of variables, coefficients, and constants, right? Well, how would you write that out? Oh, it's 4, and then there's some of them. How many? You can't do it, can you? You have no idea how many 4s you're going to write here. So is that a polynomial? No. What about this? Is that a polynomial? Why? Because that is x times x times x times x. Everybody understand? So, variable exponents, no good. Everybody cool? All right. Now, the degree of polynomials. Please notice, look at how little room I have given to this. How important do you think I think it is at this level? Not very. But you need to see it because future teachers and professors get very sticklery on this. Okay? The degree of polynomials is simply the sum. What math finds me a sum? Addition. The sum of the... damn it. Sorry, guys. The greatest sum of exponents in any one term. So, 3x. How many terms are in that? Nope. Because it's a monomial, right? Okay. Sum of the exponents in any one term. Only variables. Forgot another word because I'm tired. So, how many variables are in that? 1. What's its exponent? 1. So what's its degree? 1. This is a first degree polynomial. What about this? 4x squared. What's that degree? That is a second degree polynomial. Everybody with me? Okay. 6x cubed y. What's that? That is a fourth degree polynomial. Because 3 plus 1 here. Everybody cool? You add up the sum of the exponents of the variables. What about this one? 6x squared y squared plus 4xy. The greatest sum of exponents, only variables, in any one term. 4. This is another fourth degree. Everybody good? It doesn't really affect anything except the order we write our polynomials in. And we usually write them in alphabet by degree. And here is what I mean by that. This isn't really important. If I gave you this, 3x y squared plus 4x squared y minus 2xy. To write this in official best order, we start alphabetically. What's the first variable alphabetically, x or y? X. Okay. What's the highest degree of x? X squared. So 4x squared y would go first. Okay? Then we would put the next x. Well, I've got 2 that are both x, correct? So we regard them as being equal, and we move on to the y's. So then I would do 3xy squared, because y squared has a higher degree than y, and then I would write that. Does everybody understand? Do I care? No. I don't. But I can make no guarantees for future math teachers, yeah? Okay. You guys are going to hate the next couple of things, but I'm only going to do one, then I'm giving you the rest of the night off. I'm not even going to give you homework. We are not going to do this one because you should have played with algebra tiles, the actual algebra tile in the 9th grade. You should have. If you haven't, I'm going to remind you of something. This is positive 1, this is negative 1. They are constant. This is positive x, this is negative x. Those are variables. This is x squared and negative x squared. Those are what we call quadratic. Okay? And all we use these for, they have 2 uses. But for some strange reason, the people in charge of math insist that everybody learns how to use them, even if you don't need to, even if it confuses you more. I'm only going to show you once. I'm going to put one question on the test. Hopefully you'll get it. If not, it doesn't hurt you if you can't. Okay? They have some use, and I'll explain that in a minute. So if I was going to draw this, what is this saying in math? What is this asking me to do? Javon.
I have a question.
Oh.
Is that like the big x, or like the x, negative x squared? Is that in brackets?
Oh, it would be if you were going to write it out, yeah, because the negative is part of the base. Okay. What is this asking me to do in math? If you were going to read that out in words, what would you say? 5 times x plus 1, yes? All right. So how would I draw x plus 1? How do I draw an x? Long bar. How would I draw 1? Small square, right? And how many of them do I need? 5. So if I drew that 5 times, what's my answer? How many x's do I have? 5x. How many 1's do I have? Plus 5. Everybody cool? That's what's being asked, correct? Now, one of the uses of algebra tiles is it's really good at teaching us factoring. So I'm going to show you how it teaches us factoring. Don't write down what I'm about to write down. You know what? We're almost out the door. Stop there. There's no point going to the next thing, because I won't get through it. Nothing to do tonight. Have a quick look at exponents and radicals. No math. Tomorrow we'll finish this lesson, and I won't give you any homework. Well, I kind of will give you homework. You'll be studying for your test Friday. When you finish your test before 80 minutes is up, you'll do that homework, and it'll be due when? Tuesday when you're back. Everybody good? All right.